Welcome back everyone. Today is the session 6 from the chapter of work, power and energy, and this is the Q&A session, and in this session I have taken this question from the NCERT book. You can access this question from which is given in this chapter, and the question is, a bob of mass m is suspended by a light string of length L. So this is the bob, this is the bob having a mass m. It is suspended by a light string and it is imparted a horizontal velocity va at the lowest point a, such that it completes a semicircular trajectory in a vertical plane. That is, it reaches this point b, and at the string becomes slack when it reaches the topmost position. That is, at this point b, the string becomes slack. So we have to find the velocity of the horizontal, the magnitude of the horizontal velocity, that is VA, and the velocity at the topmost point, that is at the point B. So this figure was also given along with this question. So in this question, what I am doing here right now, let us consider this is a surface, and this bob is hung at this point O, such that the distance between this point A and the ground, and or you can say the surface, let us say this height is h, small h, let us say. So now this is the first thing which I have considered, that this bob is hung at this point O with the help of this light string of length L, such that the distance, or you can say the height of this bob above the surface or the ground, is h. Now if this bob is able to make a semicircular trajectory in a vertical plane, then we can say that, see here, this is a string, that is OA is the string. So this tension will be acting in this direction, that is in the upward direction, and this tension in the string will provide the necessary centripetal force for to this bob in order to complete this semicircular trajectory. So we can say that now the weight of the bob is acting downward. This is the height of the bob from the ground, which I have written it here right now, and this is the weight of the bob, which is acting downward. So for this bob to move in a semicircular trajectory, this tension in the string will provide the necessary centripetal force, or we can say that is this tension will be acting in this direction, the weight will be acting in this direction. So the net force which will be acting in the upward direction will be equal to T minus mg, and this upward force, that is T minus mg, will be providing the necessary centripetal force for this bob to complete the semicircular trajectory, and this centripetal force will be equal to mv square. Here the velocity of the bob is va, so this will be equal to va square by L, where L is the radius. So in this case, the radius will be equal to the length of the string. So this is the equation which we have got, that is the tension in the string will be acting in this upward direction, the weight will be acting in the downward direction. So the net force, that is T minus mg, will be providing the necessary centripetal force in order that this bob is able to complete the semicircular trajectory. So this is the first equation which I have got. Now here it is written that the string becomes slack when it reaches the topmost position. That is, at this position, the weight of the bob will be acting downward. But since the string has become, this is the first equation, I am just writing as 1. Now at the point B, tension in the string will be 0. Tension in the string will be 0 as string becomes slack. It is written in the question. So since the string becomes slack at the topmost position, so the tension in the string will become to 0. So at this point, the weight of the bob will be acting downward, that is mg, and the centrifugal force will be acting in this direction, which is equal to mv squared by r. So at the point B, this mg will be equal to mvb square by L. At this point B, the weight, this mg, that is the weight of this bob, will be equal to the centrifugal force, which is acting in the outward, in the outward direction. So from this equation, it implies that if I just cancel it out, Vb square is equal to GL, or it implies that the velocity of the bob at the topmost point is equal to under root of GL. So the first thing is we have calculated that the velocity of the bob at the topmost point will be equal to under root GL if the string becomes slack. So this is the first thing which you have got, that is Vb is equal to under root GL. Now we have to find the velocity at the point A, that is at the bottommost point. So first equation we have got it, that is the tension at the bottommost point. The tension will be acting in the upward direction, the weight will be acting in the downward direction, and this will be equal to this force which is acting in this upward, that is towards the center, will be providing the necessary centripetal force for this bob to move in a semicircular trajectory. Now at this point A, the total energy, the total mechanical energy in the bob will be equal to total mechanical energy at A. This will be equal to half m, that is the kinetic energy, because here we have this bob is imparted a horizontal velocity va, so that the kinetic energy will be equal to half mva square plus the potential energy. The potential energy will be equal to what? M into g into h, where h is the height of this bob from the surface of the ground. So this is the total mechanical energy at A, and the total mechanical energy at B this will be equal to, the total mechanical energy at B will be equal to, that is half m Vb square. This is the kinetic energy of the bob at this point B plus the potential energy. Now potential energy is equal to how much? This is h, L plus L. This is the radius. So the height, that is the height of this point B from the ground, will be equal to 2L plus h. So m g 2L plus h. Now, since the total mechanical energy of a system is conserved, therefore we can say that it implies that half mva square plus mgh will be equal to half mvb square plus mg 2l plus h. So this is the equation which we have got using the principle of the conservation of mechanical energy of a system. That is, as per the principle of conservation of mechanical energy, the total mechanical energy of a system is conserved if the forces acting on it are conservative in nature. So we are using the same we are using the principle of conservation of mechanical energy in order to solve this question. So the equation which we have got is this one. So now I will be solving this equation, and with the help of this equation we will be able to find the value of VA. So from here you can see that this M, and M, these all will get cancelled out. So finally what I am getting is half VA square plus GH is equal to half VB square plus, I will just open this bracket, this will go to 2GL plus GH. Now here GH and GH will get cancelled out. Okay. So what I am getting is half VA square is equal to half VB square plus 2GL. Now we have found the velocity at the topmost point, which was equal to under root GL. So I will be substituting this value in this equation. So it implies that half VA square is equal to half GL. VB square will be equal to GL. So I have substituted this value in this equation plus 2GL. So from here I will be getting the value of VA. So this half VA square is equal to, I will be taking GL as common, and I will be getting half plus 2. So this is equal to 5 by 2 GL. So it implies that VA square is equal to 5 GL, or it implies that VA is equal to under root of 5 GL. So the velocity at the bottommost point, that is at the point A, is equal to under root of 5 GL, and the velocity at the topmost point was equal to under root GL. So I hope you have understood the solution of this question, and so thank you very much for joining this session. In the next session I will be coming up with another question, and it will be based on the topic of the principle of conservation of mechanical energy. So thank you very much and have a nice day. Bye.